Hey guys, welcome back. Today is not really new information, but I may have to just remind you of a couple of things. We're going to do area and volume again, but today's problems, each problem has like one question that's a little bit trickier. So I want to give you a heads up to try to help you predict how to do those, okay? So I'm not doing any of the specific problems right now, but you're going to see that this will help you do those problems. Okay, so first, a quick review of area when the curves intersect in more than two spots. Let's say you have a curve that goes like this, and maybe another one goes like this, whatever, okay? Sometimes they want you to find the area of both regions. Sometimes they only want you to find the area of one, so just pay attention, make sure you read it carefully. All right, well, if I was trying to find the area of both of these together, the first thing I would need to do is find these points of intersection. I'll call them A, B, and C. Well, if this is a calculator question, then you have to use your calculator to find those, or you won't be accurate enough. Don't just hit trace. Make sure you use the intersect function on your calculator. Then write down those values and maybe even store them if you know how to. Do not round those values. Do not round until the very end of the problem. If you round here, you will not get the final answer right because you will have rounded too much too soon, okay? So don't round to the very end. Leave all those digits in your calculator or store all those digits in your calculator. Then when you do round at the very end of the problem, always round to the nearest thousandth for the AP exam. Always 3 digits. So now to review how to find that area, make sure you know they will tell you 2 equations, f of x, whatever that is, and g of x, whatever that is, but they won't tell you which one is which. So first make sure you figure out which one is which, okay? And then if this was f of x and this was g of x, and again, don't assume that that is what's going on for your problem that you do today. I'm making up a new one here. Okay, if that's the way this was, then the area of this region would be the integral from a to b of f of x minus g of x. But then those 2 curves reverse for this one because it's always got to be top to bottom. So this one would be g of x minus f of x. Okay, in addition, where I wrote a and b here, as long as you write down what their values are, you can leave it like that on the exam and then just put it into your calculator like this. This is the safest way to write it, okay? Now, when you go to put it in your calculator, make sure if g of x has more than one term, make sure you either distribute or use parentheses around it. Okay, and again, don't round to the final answer. Do not round these. Even though you can write down a rounded value here on your test and still get credit, you don't want to round it when you actually use it. Okay, the next thing that might be a trick is there's one question, and this is not a you get it every year kind of a question, but this concept's not so bad and it gives me a chance to review a few things at once. There's one question that asks you, it tells you that h represents the vertical distance between the curves. Vertical distance between the curves. Let's say this is f of x and this one's g of x again. Okay? The vertical distance between the curves, what would that be? Because they don't tell you. You have to write an equation for it. Well, the vertical distance between the curves, that's this, and hopefully you know that's just f of x minus g of x. Okay, that's the first thing. That's the distance between the curves. Well, the next thing they do is they ask, how fast is that changing? Well, this vertical distance is different than this one, which is different than this one. So the vertical distance between the curves is changing. But they'll say, how fast is it changing with respect to x? Okay? Well, when they say how fast it's changing, they're asking for a rate. And a rate just means derivative. Well, now once you figure out you need a derivative, make sure you pay attention to what it's with respect to. Because if it's with respect to x, then that's easy. I'll just do the derivative of each of these. That's normal. Okay, so the rate that it's changing would be the derivative. And that would just be the derivative of this guy minus the derivative of this guy. No big deal. Okay, so that would be real easy. And then, by the way, if they say how fast is it changing at a certain point, you plug that number in. Let's say how fast is it changing at 2, and you probably would use n-derive on your calculator for each of these. Okay? Make sure you use your calculator when it's a calculator question. N-derive at 2, if that's the point, okay? All right, now back to the rate thing again. What if they said how fast is it changing with respect to time? Okay, and this particular problem, the one that's similar to this one on the problems that I gave you, it's not going to be with respect to time, but another one is. So be warned, if it says with respect to time, then you're only allowed to differentiate t's, and these aren't t's. So every time you'll do a derivative, if it's a derivative of an x term, you'll have to tack on a dx dt each time. Okay, so quick review of that. Making up a random equation, if I said how fast is it changing with respect to time, okay, then I can only differentiate t's, and none of these are t's. So this would be 6x dx dt. This would be 5 dx dt. Every time you do a derivative, if you don't do a derivative of a t, you have to tack on a chain rule. Okay, that happens in another problem. It's not the one with the h, but the concept is the same. Okay, the next thing I want to warn you of is, what do you do if your curves do something like, let's say you have one that goes like this and one that goes like this. It looks just like that, but not quite, because it's not at 0. But whatever. I'm going to make up, I don't want to give you the exact answer. I want to hint at it, okay? All right, so you have two different curves. If you need the area of all of this, okay, then first we need to know this point of intersection right here, because the area of this region is using these two curves, but the area of this region is using these two curves. So use your calculator to find that point of intersection and write down what it is, okay? And store it. Then to find the area, you would integrate f of x minus 0 if that's the x-axis, or just f of x, from whatever this is to this. So if this is 0 to whatever that point is. Okay, then to get this region, we would integrate again from a to whatever this guy is. I think they give it to you though. And that would be g of x minus 0. Okay, and again, if you tell them what a and b are, you're allowed to leave it written like that in your bounds. Okay, that's the first thing. Now that's the way I would do this problem, because I think that's easiest and quickest. But I want to point out that there is another option. If instead of visualizing strips that go this way to get area, which is what I just did, if instead you visualize your strips going horizontally like this, okay, you could also get the answer that way. And now the distance between here and here would be g of x minus f of x from right to left, and then we would add them all up. But if you do that, just like volume, then you have to change everything to be in terms of y. Okay? I personally don't think it's easiest for this problem, but there's another part later on where it will be easier. Okay, so remember, if you decide to do your area going this way instead of up and down, then everything has to be in terms of y. So for this problem, it would be, I would have to rewrite this in terms of y, whatever that is, rewrite this in terms of y, whatever that is. Then I would integrate from bottom up, so it would go from 0 to a, and it would be distance between curves, g of y minus f of y. Okay, now again, you don't really need to do it like that for this problem, but part C later on, you'll want to change it to be y strips in order to make it easiest. You'll see when you get there. Okay, last thing. There's a couple where they'll give you a line, and they'll say that there's a line that divides the shaded region into two equal parts. Okay, and they don't ask you to find what the value of the line is. They ask you to set up an equation that would allow you to find it if you could. So pay attention to whether it's a vertical or a horizontal line first. If it's a vertical line, it's easier. So first try to visualize, okay, maybe that cuts it in half perfectly. And they're going to say it's the equation x equals k is your vertical line. They're going to give you that. So this is k right now. And let's say this one's 0, and this is whatever you found it to be. I don't know, whatever it is. Let's call it, I'm going to say it's maybe it's a number that's clear. I don't know. Let's call it 5. All right, so write an expression or an equation. Write an equation that would solve for k with an integral expression such that this line x equals k divides the region into two equal parts. Okay? Well, that means this part has to be equal to this part. So the area here, assuming this is f of x and g of x, would be the integral from 0 to k of f of x minus g of x. And that has to equal the other integral, this guy over here, which would be the integral from k to 5 of f of x minus g of x. And that's it. They just want you to set it up. Okay? So they're going to give you this line, x equals k, and they'll say it divides it into 2 equal parts. Okay? And that's it. You don't have to solve it. You just set it up. All right. Now, what if that line is horizontal instead? Then it's a little harder. And that ends up happening on the question that looks like this. They say now there's a line, a horizontal line, y equals k. So that divides it equally. So now you go, okay, there's y equals k. Oops. And now this area has to be equal to this one. Okay, and there's 2 different ways you can do it. So again, let's just say that this is the curve f of x, and this guy over here is g of x. Okay? Well, now, since it's a horizontal line, you're going to want to get your area going this way. So this is the one where you will have to write it in terms of y. So you'll want to change your equations to be in terms of y. And your area from 0 to k, this guy, of this equation minus this one in terms of y, is going to be equal to the area of this region from k to whatever that point is, okay, of same equations, this guy minus this guy, in terms of y. Okay, that's one option. You could also say that this area is equal to half of the total. And you had found the total in a previous part, so that's the other option. Okay, so hopefully that helps. I didn't really solve anything. I just wanted to give you a couple of hints on the tricky ones today. Let me know if you need anything. Hope you're doing well. Bye.